Hey guys, and welcome to this video. So in this video, I'm going to be talking about OSI Model Layer 4, or the transport layer. Let's recap what we talked about in the last video. In the last video, we talked about OSI Layer 3, or the network layer. And the network layer handles logical transmission between devices on different networks. It performs three different functions. You have logical addressing, routing, and encapsulation into and decapsulation from packets. Starting with logical addressing, a logical address uniquely identifies a device across different networks and can change depending on the context. Now, for routing is the process of directing packets to its destination, and we use devices called routers to perform routing. Now, in a router, it creates a routing table of destinations and how to get there, and each entry within the routing table is called a route. Now, route information can come from three different places. You have directly connected networks, static routing, and dynamic routing. With static routing, it is fixed instructions on how to get to a network, and these are easy to configure, hard to maintain, not very flexible, and not optimized. With dynamic routing, it continuously calculates how best to get to a network, especially upon a change in the network. But it is harder to configure, it is more flexible, and the routes are optimized based on some metric. Now, the network is said to have converged when all routers are at a stable state and has consistent routing information, and that's a very important concept in dynamic routing. Now, there is a big issue that the network engineers need to solve in routing, and that is routing loops. And routing loops occur when packets are forwarded back and forth among multiple routers. And routing loops can cause performance issues in the entire network, or in the worst case, it can potentially crash routers and take down the entire network. We also learned about autonomous systems, which consist of devices under the management of a single entity. Now, routing protocols can be classified based on purpose. The first is IGP, or the Interior Gateway Protocol, and these are protocols that are used for routing within an AS, such as within a company. Then you have EGP, or the Exterior Gateway Protocol, which are protocols used for routing across different ASs, such as between companies. Routing protocols can also be classified by operation, and there are three types. First is the distance vector. Distance vector protocols exchange information with direct neighbors only. It does not have the full topology, and it provides periodic updates of the full routing table, even when there are no topology changes, so it's not very efficient. It is not loop-free, but it does have low resource usage and requires low expertise to configure and manage, and it is mainly used by IGP protocols. We also have link state protocols. Link state protocols exchange information with all routers on the network, which means it has the full topology. Now, for updates, it only updates upon a topology change and only sends the topology changes. It is guaranteed to be loop-free, but it does have high resource usage because you need to process the full topology, and it requires high amount of expertise to configure and maintain. And it is mainly used by IGP protocols. And lastly, we have the path vector protocol. Path vector protocols exchange information with direct neighboring ASs only. It does not have the full topology. It only sends updates when there's a topology change, and the updates only include the parts that have changed, so they're very efficient. It is guaranteed to be loop-free, but it has high resource usage, and it requires high amount of expertise to maintain and configure. It is mainly used by EGP protocols. Now, so far, we've talked about layers 1, 2, and 3. And these three layers together have helped us transmit data from the source device to the destination device. And these are often classified as the mediate layers. Now, starting with layer 4, transport layer, it is all about the end device. And these are classified as host layers. So let's talk about transport layer. The transport layer handles logical transmission of data between different processes over the network, and the emphasis is on processes. It provides a number of different functions. It provides service point addressing, connection control, flow control, error control, and segmentation and reassembly. Let's start with service point addressing. The service point address uniquely identifies a process on a device that's trying to communicate over a network, similar to the physical address in MAC layer and the logical address in the network layer. Now, different protocols can use different service point addressing schemes, but the most common you'll see is called the port number. The port number is fully software-based, and because there are different port numbers that are available, you can run many different applications as long as you have enough port numbers. Next, we have connection control. And a connection establishes a channel between the sending process and the receiving process, and there are two types within the transport layer. First, you have connection-oriented, and that's where the protocol tries to pre-establish a channel before transmitting. And by doing that, it can provide some guarantees. For example, it transmits without loss or error. Now, you also have connectionless protocols, where it transmits without pre-establishing a channel. And that provides no guarantee on loss and error, but it has some other benefits that we'll talk about in a future video. Now, the path from the source to destination contains many factors that can affect the network performance. For example, the number of hops that the data needs to go through, the bandwidth of each hop, the delay, and congestion. And together, these may lead to things like loss of data or slow transmit speeds. And that's why we use something called flow control. Flow control is all about controlling how fast the sender can transmit the data to the destination, which reduces the probability of a loss of data, and it transmits at the highest possible speed. Now, flow control is great, but the network is still not perfect, and it may result in errors. And error control ensures the entire message is received without errors. Now, just like in layer 2, a calculation is performed per segment of the transport layer, and the value is added to the segment to detect any errors, and that's called a checksum. Now, in this case, errors are corrected through retransmission, and also any loss of segments are corrected through retransmission. Lastly, we have segmentation and reassembly. Now, upper layers can provide large amounts of data to transmit within a single message, and the network may not be able to accept that large amount of data within a single message. And also, transmitted data can arrive out of order, so you need a way to put them in the right order. Now, at the center side, layer 4 breaks down the data into smaller chunks for transmission, and that's called segmentation. And at the receiver side, layer 4 reassembles the data in order, and that's called reassembly. And also, you have to encapsulate into and decapsulate from segments. These are some of the references that I used to make this video, and that's it. Please like and subscribe and leave a comment down below. Let me know what kind of security issues that you can see happening at layer 4. Thanks again, and I'll see you in the next video where I will talk about layer 5, which is the session layer.